Now, if you have, the first thing you want to do if you have this is do the division. Division makes us do what? Subtract. So it's log 2 to the 4th minus log of 5. The 4 goes out front, so this is 4 times the log of 2 minus the log of 5. All right, number 7, same thing. We're going to do its division, so what operation do we do? Is it the log of x plus the log of y to the 6th, or is it the log of x minus the log of y to the 6th? Yep, minus the log of y to the 6th. But we're not done. It's not everything. We haven't done everything. That 6 is going to go out front, so we're going to get the log of x minus 6 times the log of y. So as long as you're doing this stuff step by step, you should be okay. If you're trying to do this stuff all in one step, don't. Step by step is the way to go. So this is the log of u to the 4th minus the log of v. Bring the 4 out front. 4 times the log of u minus the log of v. This guy was a little bit of a contention yesterday. What do we do when we have a square root? Well, remember that the cube root is really, if we have the cube root of x, that's x to the 1/3 power. So this is really equal to the log of x, y, z to the 1/3 power. Take the 1/3, bring it out front. And then you're going to get the log. And all this is in parentheses because you have x to the 1/3, y to the 1/3, z to the 1/3. So you get the log of x plus the log of y plus the log of z. So it's 1/3, and then you have everything in parentheses here. And that should take care of everything. Now, if you didn't do that, and you said, well, it's the log of x to the 1/3, y to the 1/3, z to the 1/3, you'd end up with 1/3 log x plus 1/3 log y plus 1/3 log z, because the property of exponent says if you have something raised to a power, everything in there gets raised to that same power. So everything has the same power. And so everything has a 1/3, and then you factor out the 1/3, and you're left with this in simplest form. What we're going for. This guy, log of 5 times 3, it's log of 5. Is it plus or minus?
Plus.
Plus log of 3. Now, 3 times 2 to the 3rd, are we going to add, when we separate them into logs, are we going to add them or subtract them? Log of 3 plus or minus, what is it, plus or minus? Plus log to the 2/3. Now this guy, we have 2 to the 3rd power. We're going to bring out the 3. This is going to be the log of 3 plus 3 times the log of 2. Here you're not quite done, because you have an exponent in there, so we have to get rid of the exponents. Now this guy, what are we going to do with the exponent first? No. Well, yeah, yes. Multiply it to the whole log, but we bring it out to the front of the log. So we got our 6 times the logarithm of 6 over 5. Now, since 6 was, this would be 6 to the 6th over 5 to the 6th. So this would be, 6 we should see now is 2 times 3. So that's going to be the log of 2 plus the log of 3, and then we're dividing by 5, so we subtract the log of 5. No, tomorrow. Sorry. Tomorrow. We have school tomorrow. Tomorrow's 4, 5, 6. You guys are 4, so you're in school tomorrow. I would say that tomorrow would probably be a better time to take the test than Monday, because Monday would be Monday is, well, you won't have school, but Tuesday you'll have a different you'll have a different test covering the same material, whatever that means. All right, now to expand this guy, first we do the exponents. So exponents go first. If there's an exponent out in front of everything, we bring that out in front, and then we just take care of the multiplication and division. Log of A plus log of B. Now, since in this case y is the only one with a power, it's nice to see you guys are holding hands back there. We're going to get log of x minus the log of y to the 5th. It's always been legal, at least in your lifetime.
Everything's legal when the cops aren't around.
So the answer for number 10 is log of x minus 5 times the log of y. Now this guy, we're multiplying and we have a power. Yeah. They go before the log. For number 8, if it's a bunch of stuff in parentheses to a power, we go out in front and then we have to put the log in the parentheses, because of the fact that AB squared is really A squared times B squared. So instead of really doing like the log of A squared plus the log of B squared and then having to take the 2 out, this simplifies it down to a little bit of step. You take the 2 out first and then you put it out in front like this. Yep. Yesterday we came up with something kind of neat. If you take multiplication like this and you turn it sideways, it looks like a plus sign. So adding and multiplication go together because their signs are really similar. If you take a division sign, it looks like a subtraction sign. You get rid of the dots, you're good to go. Now, I'm going to do this one pretty quick. X times y times z squared. Since we're multiplying, are we going to add or subtract? Add. So we get log of x plus the log of y plus, I have an exponent of 2. Is that going to, what's going to happen to the exponent? Goes before the log, and then we get 2 times the log of z. The more you work with this, the more that expansion is pretty simple as far as that goes. So any questions on that first page? Sure. All right. Now, number 11, it takes a riff off of the fact that, like, if you have the square root of x, that's x to the 1/2 power. Because we can take the square roots and make them into what we call rational exponents. if we have the cube root of x, that's x to the 1/3 power. If we have the fourth root of x, that's x to the 1/4 power. If we have the fifth root of x, that's x to the 1/5 power. Yep, if it's the 10th root of x, it's x to the 1/10. Now, if you take the log and you have xy to the you have the square root, you don't have a square root, but say you have the 7th root of this, the first thing that you have to do, since, here's the thing, a lot of times we don't have a method for a square root or a root of any kind. So what we learned this year was to convert the root to a rational exponent. And so we take the log of xy and raise it to the 1/7 power. So we take the 7th root of x, and we know that's going to be something to the 1/7 power. So that makes it a lot easier, because then the rules apply. We don't have a rule for the logarithm of any type of root. But as soon as we change it into a power, then we can say, oh, that 1/7 has to go out front. And then all of a sudden, we have just xy that we have to deal with, x times y. So you get log of x plus log of y. And the key is, since the power is outside parentheses, we have to put everything after the power in parentheses. Because these two things are in parentheses, so when we expand them, they have to be in parentheses as well. So don't lose your parentheses, because then if you ended up just doing this, log of x plus log of y, and you forget to put that 1/7 with the y, this really means the log of x to the 1/7 minus plus the log of y, which is equal to the log of x to the 1/7 y. And you miss out on that 1/7 power being applied to the y variable. So you have to be careful. If the exponent is associated with stuff in parentheses, then all of a sudden, whatever you do with the logs has to be in parentheses after you move the exponent out front. Does that help? Alright, log of 3 minus log of 8. Minus is division. So I can rewrite this as a log 3 over 8. Now, if I have a coefficient out in front, what can I do with that coefficient? Make it an exponent. So we get two that have the same exponent. So, and we have a subtraction, so what are we going to get? Division. So I'm going to get the log 3 to the 4th over 8 to the 4th. And that's because there's a 4 and a 4 for both of those. Now how about these guys? I have an exponent, or I have a coefficient. That becomes an exponent, doesn't it? I have subtraction. Does subtraction mean addition or subtraction? Or, I mean multiplication or division? Division. So I'm going to get the log of 7 over 12 to the 2nd power. Now number 16, there's 3 of them, and I'm adding both of them. So what does that tell me that I'm going to do? Well, I'm going to multiply. So this is going to be the log of 2 times 11 times 7.
For number 15, can it just be a log 3 over 8?
To the 4th power? Yeah. 77 times 2, 70 would be 140. This would be equal to, if you multiplied it out, 154. You should. If you have this, you should be able to make it to your simplest form. Now, in a case like this, you have 2 over 3. Rewrite this as 2/3 times the logarithm of 7. Now, what am I going to do with that 2/3? What does that become? An exponent. So this is going to be the logarithm of 7 to the 2/3 power. And if you remember back to probably, I think it was first semester, we found out that we could actually have 2/3 power. Yeah, 14 is the same way. It's over 3. I changed it to 1 over 3 times the log of x. Or the log of 6. And so it became just the log of 6 to the 1/3 power, which is this value right here, but we don't know how to do that. Well, yeah, we do know how to do that. We dump it in a calculator, right? So, in that case, that's all we end up doing. Now, here, this is going to be equal to the log base 3 of u to the 6th plus log base 3 of v to the 6th. Now, anybody disagree with that? When you're adding, what are we going to do with these two guys? Multiply them. So we're going to get the log of 3, u to the 6th, v to the 6th. And you can rewrite this as uv to the 6th power. So because everything is raised to the 6th power, we can actually bring it out to the front. I would actually accept this or this. Both of those are okay in my book. Now, number 20 is this natural log. This is an ln. The same rules apply. And I'm going to show you today what the natural log really means. But natural log of x minus 4 times the natural log of y. This is the natural log of x minus the natural log of y to the 4th. What happens when you subtract? You're really dividing. So it's the natural log of x over y to the 4th. Alright, now, subtraction, I moved the 6 to a power because 6 is a coefficient. Now, what is, when we subtract, we divide, yes. Log of 4 is equal to u over v to the 6th. And you're done with that guy. Same thing here, I'm going to take that 5 and I'm going to make it into a power. So it's log base 3 of u minus log base 3 of v to the 5th power. Now, here, I haven't really stressed this at all with you guys, but as long as these bases are the same, we can do the properties. If the bases are different, you can't do anything with them. If that was a base 4 and a base 5, you can't really combine them because you're talking about 2 different bases, and it doesn't really work. It's like saying I have 7 to the 10th power times 10 to the 15th power. You can't combine them because they don't have the same bases. And the same thing with logs. If you don't have the same bases, you can't combine them. But we do have the same bases. So subtraction gives me come on. base 3 of u divided by v to the 5th. Now I have tons of coefficients going on here. So this is going to be log base 6 of u to the 20th plus log base 6 of v to the 5th. Now what happens when I'm adding? It becomes multiplication, so it's log base 6 of u to the 20th times v to the 5th. Alright, now your critical thinking ones. Order of operations are the key to the day when you're thinking about these. Do the stuff in parentheses first. So we're going to get 2 times. What happens when we're subtracting? You divide. Thank you. So we're going to get log of 2x over y. So we get 2 times the log of 2x over y minus, now what's in this parentheses? That 2 goes up top. I have a plus, so I'm going to multiply them together, right? So I'm going to get the log of 3 times 5 squared. So now I have to use this guy, and it's going to be a power. So this is the log of 2x over y quantity squared minus the log. Well, what's 5 times 5? 25. Times 3 is, you got 3/4. How much do you got? 75 cents. Now, I'm going to actually distribute the power of 2. What's 2 squared? 4. What's x squared? Just x squared. What's y squared? Y squared. Now minus the log of 75. So what does that minus tell me I have to do? Divide. So division is just going to put the 75 in the denominator. So I'm going to get the log of 4x squared over 75y squared. And that's your final answer for that guy. Now for 26, no rules, can't simplify. 26, since we're multiplying in that case, you can't simplify those together. So unfortunately, there's nothing we can do about that. I messed around with it yesterday and said, well, technically this means that since I'm multiplying, this becomes an exponent of this, and then you get the log of 2 to the log of x power, but then there's really nothing to do at that point because the bases don't line up, and so you can't do anything with it. So this is like an exercise in futility. You just made it into a different type of problem that's going to be the same answer no matter what. So there really isn't too much you can do with that.